Now question 3. Use the information in the table below to answer the questions that follow. The letters do not represent the actual symbols of the elements. So we have elements from R up to V, W. We are given their atomic numbers and the melting points. Okay, so before we start, maybe we try and give the electron configuration based on the atomic numbers. T will have 285, U will be 287, V will be 288, and finally 2881. Okay, give reasons why melting point of S, okay, maybe give reasons why melting point of S is higher than that of R. So we have R and we have S. S, where are you? Okay, these two. You notice something about these two. They belong to period 3, both of them, but different groups. So the reason here is because of the type of bonds. So these are 81, S is 282. So you notice that S has 2 electrons in the outer energy level as opposed to R that has 1 electron. So S has stronger metallic bond. Due to its more number of delocalized electrons. So the number of delocalized electrons are more. S has 2 delocalized electrons and R has a single electron, delocalized electron. It is this delocalized electrons that carry an electric charge. So if there are 2, definitely there will be more than that which has 1. V is lower than that of U. So V, if we go revisit V, okay, V is 288 and U is 287. This is diatomic. This is monoatomic. So we will say here U has stronger van der Waals forces than V, because U is diatomic while V is monoatomic. So that is actually the reason. Scroll down to other questions. Yes, but B, how does the reactivity of W with chlorine compare with that of R with chlorine? So W is, we say W is 2881 and R is 281. So both of them belong to group 1. Group 1 elements, the alkali metals. And we are to use here a comparative term. So how do they compare? W is W is more reactive with chlorine than R with chlorine. The reason is W has higher, or if you like, greater atomic size than R, hence ease of loss of electrons. And now write an equation for the reactions between T and excess oxygen. So T, solid, oxygen is in excess. So not when it is limited, there is a different oxide. When it is excess, we get a different oxide as well. So this is oxygen gas. You get, in excess, we have phosphorus 5 oxide. Okay, we need to balance this by placing a 2 and placing a 5 here. Okay, so this one is the excess. But if it is not in excess, then we have, when there is limited air, we get this oxide. This is when not enough air is available. Not enough air is available. Not enough air is available. And now we go to part D. When 1.5 grams of R were reacted with water, 600 centimeter cubic of gas was produced. So 600 and 1.5 grams. Determine the relative atomic mass of R given molar gas volume at RTP is 24,000 centimeter cubic. So first we write the reaction R reacting with water. You get the hydroxide of R, which is in solution, plus the gas that we are talking about, hydrogen. And now balancing, we place a 2, place a 2, place a 2, looking through both the reactants and the products. The reactants and the products are balancing out. So then next is we find, or rather calculate, the number of moles of gas produced. So if 24,000 centimeter cubic is occupied by 1 mole, so how many moles are 600 centimeter cubic? This gives us, the value comes to 0.025 moles. And now, looking at the mole ratio, we have mole ratio. Can I refer you to the equation? Look at R. We have 2 moles on the equation, but we have 1 mole for hydrogen gas. So mole ratio hydrogen gas to R, you have, okay, 1:2. If you know this is 0.05 moles, 0.025 moles, 0.025 times 2 all over 1, and you have 0.05 moles. Okay, at least now we now know. So 0.05 moles is same as 1.15. What about 1 mole? It will be 1.15 times 1 all over 0.05. And the answer we get here is 23. So the relative atomic mass is 23. Remember, no units, because this is relative atomic mass. No units. If you put units, then you will be committing an offense. Now give one use of element V. Element V is 288. The in bulbs, in fluorescent bulbs, to provide inert environment. It is used also in welding. Okay. So we have two. You can refer to chemical families to be able to understand more on these terms of, because this is actually from 2, the atom, topic 1, which is very crucial. Okay. Question 4, part A. But just a moment, and then we need to refer something first before we embark on part A of question 4.